students. And here we go. Hello, everyone. Welcome to lesson 28 of the live summer sessions to get everyone ready for algebra and geometry this coming year. I'm going to give everyone just one more minute to jump on, make your way over to the floridamathlive.com. Okay, that one is up. Make sure the other camera is operating. Okay, so solving problems using scatter plots. So yesterday we introduced scatter plots and we talked about whether there's a positive association or a negative association, a strong association or a weak association or no association. So this example down here would be an example of a positive, I could argue whether it's probably a medium association. The dots could follow a narrower hallway or they could be wider. Today we're going to actually make some decisions on solving equations using scatter plots. So let's go ahead and get started with that. So you can find an equation for a straight line using the slope and the y-intercept. We worked on this earlier this summer. The slope of a line is the ratio of the change in the y-coordinates as compared to the change in the x-coordinates. The y-intercept is the value of y when x equals 0. An equation in this form is called the slope-intercept form. Okay, so the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept, okay? So when a scatter plot has a trend that is linear, you can estimate the equation for the line of best fit using ordered pairs from the scatter plot. A graphing calculator or spreadsheet program will calculate a more precise equation for you. So let's look through this example here. And there's a few more steps. I'm going to follow the book's example. The print might be a little bit easier to follow on this first one, and then we will work through the next one by hand. So example 1 asks us to estimate a line of best fit equation and use it to estimate the number of downloads for a song with a 4-star review. So keep in mind, it looks like we're going to need to find a few intersections where this line goes through some intersections on the grid. We're going to use that to find the change in y's and the change in x's. We're also going to use the y-intercept, and we're going to make an equation. So that way, we're going to be able to ultimately, at the end, plug in 4 for a 4-star review. And essentially, what we're doing is, so after we drew this line of best fit here, right, we try to make it go right through the middle of all points and try to make it a nice, happy average for those points. So what we would be able to do then is we would be able to find an estimate for how many, maybe we're just curious on if we do have maybe some friends or data points that were able to publish some songs on iTunes or something. We want to see how many downloads they got. So we were able to put these data points in as points that we knew. Maybe we found that data where we had friends that had that number happen. They would know how many downloads they had over here per day, and they know what their 4-star review is. So you might say, okay, how many, if I did end up getting a 4-star review, then what would I expect as far as daily downloads, right? So I'm going up from this 4-star. And we would work our way across. So it looks like our common sense solution is going to be finding around 34. So let's see if we can actually use the equation to figure that out now. So when we're going to find the y-intercept, so they extend the line of best fit until it meets the vertical line for 0 stars. So the line approximately goes through 0, 1. So the y-intercept is 1. Okay, that would make b equal to 1 in the equation of y equals mx plus b. So what they did is, after drawing their line of best fit, they extended it. It's a different color here. They extended it down like so. And the more accurate you draw this, the better idea you're going to get. It looks like it didn't quite go through the origin 0, 0. It looks like it's going through the point 0, 1. Right? So if we start at the origin, we're not going left and right whatsoever. And we're going up to about 1. See how it's about 1/5 of the way to this first label on the y-axis. So that's where they find the 0, 1. That's the same 0, 1 you see here. And we would be able to plug in that y value of b equals 1 in there. So we're slowly constructing an equation for this line. And after we're able to work on and find the slope, maybe we'll kind of start to underline that in blue. So after we find our slope, we already found b. Okay, so let me go ahead and start to write down. Trying to use a different color pens here. So y is the unknown. That's the amount of downloads that we're going to hope to have. And we still need to find our m. So we need to find that. We're going to find that in a minute. And that's times x. And what we're going to plug in for x is 4, right? So remember, if we were estimating this off of a 4-star review, that's what would go in for x. And we did find b already. We found b to be 1. Okay, so hopefully that kind of gives a little bit of a visual. So this is the y equals mx plus b, and this is as we start to find the data, find the numbers that we can plug in for those variables, we'll be able to find y. And how do we find m? That's the only other thing that we need before we can solve for y. So what they do is they find 2 spots where the line goes through, right through one of the grid intersections. And they decided it looked like it did a good job of going right through 0.5 and 5 and 2.5 and 21. So I'll identify those spots on here. So they thought it went right through some grid lines at, again, 0.55. So they chose that point as one of their points they're going to use to calculate the slope. And the other spot where it went through, see how it went through like a nice, like right through that intersection of those grid points. Another point that they chose that it went right through an intersection of grid lines is 2.5 and 21. So go over to 2.5, and they chose 21. I'll do that as well. Yeah, see, I guess I might have chosen 3 and 25. Because it goes right through that intersection. They felt pretty confident that they knew that this went right through 21, but that's what they ended up choosing. Okay, so what we're going to be able to do then is we're going to find a slope between those by looking at how much rise versus how much run is happening. So if we were extremely accurate with our graph, we'd be able to count how far that is, count how many steps we rose vertically over how many steps we ran horizontally. But of course, we're going to be more accurate if we actually have numbers for those. So they did the old m equals y2 minus y1 over x2 minus x1. Okay. And again, it doesn't really matter which one you choose for x1, y1, x2, and y2 as long as you don't twist them. So they chose over here to be their x2, y2, and x1, y1. And when you plug those into that formula and start to simplify, so 21 minus 5 is 16, and 25, 2.5 minus 0.5 is 2, and that simplifies to 8. So after we find m, we can plug that into this formula up here that we were working on. Okay, so here's the 8 that we just found. Here's the 1 that we found earlier by looking at where it crosses the y. That's the y-intercept there. Now what they're going to do is so we have the function, we have the formula for that line, and we go back and remember we were asked how many downloads we would have with a 4-star review. So they took the m and b that we discovered, and we're going to plug in a 4 for x. Now the only letter left over, the only variable, is y. So when we simplify this, 8 times 4 plus 1, we get 33. So the solution, an equation of y equals 8x estimates that 33 downloads for a song with a 4-star review. All right. So when you're estimating the equation of a line of best fit or scatter plot, choose 2 points that appear to be on the line, and these often are not the first and last points of the graph or 2 endpoints of the line. Okay, so we're looking for where we can find a nice clean intersection to identify those points. So I'm going to do this next one by hand. Example 2. So I'm going to leave this up for just a few seconds. See if you can figure out the first step or 2 on your own, and then I will be back to work on it together in just a moment. And remember, you can go to floridamathlive.com to catch the full experience, get your questions answered, and so forth. Okay, so the line of best fit on this graph goes through 30 and 3. What did we use before? Did we use I think we used blue for our points. So it's telling us that so they made the line of best fit. We didn't have to do that this time. They're telling us it goes through the point 30 and 3.0. So they're using this as one of the points. And 52 and 2.0. Okay, so they're saying that this is 52 and 2.0. If I were doing it, I don't know, it looks like it might go right through this intersection. I might have chosen that one. Again, it doesn't matter as long as you're careful with picking something that's you're confident in being able to find that exact label. Okay, so that was our point 30 and 3, and then here's 52 and 2.0. Okay, and we're going to use those points to write an equation, then estimate the number of years an employee has been with the company if the worker was absent for 65 days. So this is a graph comparing attendance and years employed. And it makes sense, right, that years employed, as the years go on, so it's comparing how many years you've been employed and how many days you've been absent. So over here, days absent, so there's this person that's been with the company for a little bit less than 2 years, and they've been absent 60 times. So on this end, folks that have been with the company for 4 years have only been absent 10 times. So this is a negative association, which means we have a downward slope that as one of these increases, the other decreases, right? So as the number of days absent recorded increases, the year's employment decreases. All right, so that's the negative association. And essentially what we could probably glean from this data is that your employees that take the fewest days off are probably maybe your most loyal employees, and they take the fewest days off throughout the year, are the ones that have been with the company for the longest. And what it's asking is to estimate the number of years an employee has been with the company if the worker was absent for 65 days. Okay, so if they were absent from work for 65 days, we would say, how many years have they been with the company? And running out of space, we'll just do EMP for employed. Okay. So ultimately, if we were to, we're going to need to extend this line. Let's make it as accurate as we can. So I'm going to extend this line, and that's going to help us find the y-intercept. And going this way, ultimately what we're figuring out. So on a visual analysis for someone that's been absent 65 days, then we would expect the answer to ultimately say that they've been with the company for about a year and a quarter. So that's the common sense analysis that we're going to try to figure out through as we work with this. So let's figure out the y-intercept. So when we extended this line, I'm trying to make a decision on what it looks like that line goes through. If we extended it, I think we'll call the y-intercept 4. It looks like it could be maybe 4.1. I'm going to call it 4. So we'll say the y-intercept, or b, is 4. Okay, now we need to find the slope. So we know it's going to be a negative number. And what we're going to try to be figuring out then is the rise over run. In this case, it's going to be a negative rise or drop over this run. And we're going to try to find that slope. So how we do that, so m, or slope, is going to follow the formula of y2 minus y1 over x2 minus x1. And as we start to plug these in, I'll choose this as the y2, so that's going to be 2 minus 3 over 52 minus 30. Okay, so that's going to give us negative 1 over 22. Okay. And let's see if we can find a decimal for that number. What's a good decimal approximation for that slope? So 1 over 22. Let's call it, let's round it to, it did the exponential notation there. Let's do 0.05. And that's a pretty close approximation to 1 over 22 for rounding to the hundredths there. Get this back on the screen. Sorry about that. So now what we need to do is we're going to start plugging things into y equals mx plus b. Okay, so we just figured out our m to be 0.05. Need to plug in an x, and we're ultimately trying to find y. Our b was in green, right? So our y-intercept was 4, slope was, oops, made the mistake, it's going to be negative 0.05. Sorry about that. And I just wanted to make a decimal approximation, rounded to the hundredths of 1/22, 1 over 22. So ultimately, what is it asking? It's asking for if someone was absent for 65 days. So let me plug in this 65 here. And then we can actually find a number for this. All right, so 0.05 times 65 is 3.25. Now I need to make this a negative, right? So that's going to be negative 3.25 plus 4. So I say with that calculation there, it's giving us a strange number, isn't it? So how did they find, so according to the calculation, and this is based off of the observation that the y-intercept happens at 4, which is a little bit different than the graph over here. I would say that their line of best fit in the picture was off just a little bit, making this, because we were expecting something slightly higher than 1, but slightly lower than 1 is a fine calculation since we got this number just off of eyeballing it. So if we use that, then the amount of years we could expect someone to last with that many absence would be 0.75. Okay, so what did they end up using for So they used a better solution for finding, and I like this one better. The book previously was talking about finding b by extending the line, which again, if we eyeballed that, then that's where we ended up with a number that was a little bit off from what we were looking at. I do like this method of finding finding b a little bit better. See, so where we decided that b was going to be 4, by using the slope, if we find the slope first and we plug in the slope in any point, we can use any point that we're confident in. So with that one going right through the intersection would be a good one to use. That's why they use 30 and 3. So if you plug into y equals mx plus b, y, x, and your m, then the only thing left is b. So they found probably they made a little bit of a better decision of calling b 4.5 instead of 4. So we can see that by eyeballing it, we can sometimes get numbers that are not as accurate as we would like them to be. Okay, does this look like a good example? I'm just going to go through the solution they provided for this particular problem. It would take quite a while to construct the scatter plot from these points. And I want to get straight down to practicing this. I can show how you would go about plotting a few of these in this solution that they give you in the example. I just feel that I don't have any great graph paper right on hand for this, and that would take a long time to plot. What is that, about 15 points? So I'll let you read this for a minute, see if you can think of the process that we're going to use. So in this case, they didn't give us the graph quite yet. That's something that we need to do on our own. Now, I'm not going to do it. I'm going to go ahead and look through the solution they did for it. Just to save a little time. Okay. So it wants us to construct a scatter plot for this data and then sketch a line of best fit. From there, find the equation of the line, y equals mx plus b, and use it to estimate how many hours per week someone who is 35 years old would use the internet. So you can see here, this isn't two different tables. This is just like if we extended this data, it would go up here, right? So the top is internet use in hours per week. The bottom row is age. So if you look at this plot, I can walk us through just a couple of these examples. Okay, so the bottom axis over here, the x-axis, is internet use. So this would be like the x, and age is the y-axis. They went ahead and labeled that for us here, and we have the age and internet use. So let's just go through the process of where we would find. So where was the plot for 1027? So after we were making a graph and labeling this, you go over to 10 and up to 27. We'll zoom in a little bit. So the first point was 1027, so you go over 10, and then up to where you see 27 on the y-axis. The next point is 1126, so they went over to 11, right about here, and up to 26. The next point, data point was 0, so left and right, not at all. 0, 34, so they went up to 34, just below the 35 there. So we can see that if we were to plot all of these from the table, we would have something that looks like this. Then they just use their best judgment to make this line. I try to pick a line that went right in the middle of all of these points. That was the best representation of that slope. So reviewing the keywords that we talked about yesterday, this would be a strong, linear, negative association, right? It's strong because they're pretty tightly grouped. They're all pretty close to that line. It's a linear association because we would be able to represent it as a line like we did here. And it's negative because if we were walking from left to right, this would be a downhill walk. Okay, the next step would be to find the slope. So they're going to find the slope, and they're picking 2 points on this line. So they thought it would be a precise observation to find 1325. So they picked the point 13 and 25 here. I don't know if that's the one I would have picked. And they also picked 16 and 21. They probably picked those because they know the data points. Alternatively, what you could do is if you have the data already, you could actually, so they actually, because they did have the data, they picked the one that was 1325. Okay, so they picked this as their first point, and they picked 1621. So they picked this as their second point. When you have the data like this, it makes it actually even more accurate and even more precise when you do the calculation, because you're not just estimating, okay, it looks like that one goes right through the intersection. It looks like that's about 22 instead of 21 when I look at the axis. When they give you the data, you could have picked any 2 points to compare, and they're all going to give you the same slope when you do so. All right, so after plugging these 2 points in, they did the y2 minus y1 over x2 minus x1. They did the 21 minus 25 over 16 minus 13. And they ended up with negative 4/3, which we were expecting. We were expecting a negative slope, right? So that's about negative 1.3 for m. So slope of negative 1.3. Okay. Here's the slope. We're doing green for slope in this example. So negative 1.3 was the slope. Zoom out a little bit again. Now, as far as a y-intercept, how do you think they would find the y-intercept? Now, I would probably, if I was looking for the y-intercept, what did they do? So they find the y-intercept using 1325 and the slope. Okay, so they picked, you can pick any point when you do this. I might have picked one that the math was a little bit easier, but you can pick any point because you're looking for an x, you're looking for a y, and we just found the slope. So they happen to pick the point, what did they pick? So they picked 13 and 25 to find the y-intercept. So plug in 13 for x and 25 for y. The negative 1.3 for m we found a minute ago. Do the math on this, and we get to 41.9. Now we're going to find the newly found 41.9. Plug that in for b into y equals mx plus b once again. we're going to plug in the slope that we knew earlier. Okay. So now we have y equals mx plus b, and now what were they asking? They were asking ultimately for how many hours per week someone who was 35, how many hours per week do they go on the internet? So into here, we're going to plug in this 35 in for y. So it's not always in for x, right? Because we have to look back and keep track of what these axes were related to. So we are given age, we're given y, and we're going to try to figure out what their x was. So that's why they plugged in 35 for y over here. And that's just a matter of solving for x. So they find that for someone who is 35, they're probably spending about 5.3 hours on the internet per week. Okay. So let's see a couple more examples. Let's do that one. Yeah, why not? That'd be a fun one to do. Let me know if in the audience who's watching, if you have a question, if you have one of these requests that you'd like to see, I can do one of those as well. So in this example, they give us some of the outline for the problem, and we're going to see what we can do about it. So construct a scatter plot for these data and sketch a line of best fit. Find an equation for the line and use it to estimate the temperature for a location at 25 degrees north. Okay, so this isn't two separate tables, it's really an extension, so we could take this bottom table and put it over here. It's just that they ran out of space on the page. So we need to graph all of these points first, and they were nice enough to give us a scale here. Sometimes that's the most challenging part, is deciding on a scale. And how I would do that is I would look at the smallest and largest numbers. Okay, so for latitude, the smallest number is 0, and the largest number I see is 75. So when we're doing latitude, we would need to decide to range our steps down here in something that would contain 0 and 75. What about the temperature? The temperature, the smallest temperature I see is 10, and the largest temperature I'm seeing is 86. All right, so our scale on our axis here would need to contain numbers between 10 and 86. So which column is which? Now this one only went up to 80. Okay, so which piece of data, is it temperature or latitude that went up to 86? It would be temperature, right? So that means that temperature would make the most sense going on the y-axis. Temperature. And we can make latitude the x-axis here, okay? So now it's just a matter of plotting all of these points. So let's remind ourselves that temperature is y and latitude is x. So as we work through these, so latitude of 48, so I'll go about here and up to 32. out there. Holds them close in the graph. The next one is 3850. So I'm going to go over to 38 and up to 50. The next one is 0, 86. So I'll go left and right, not at all. Up to 86, about there. Now 1280, so over to 12 and up to 80. The next one is 1680, over to 16 and up to 80. So it's going to be right next to it, like right there. 3655, over to 36, up to 55, probably about there. Next is 4154, over to 41, up to 54, about here. 5236, over to 52, up to 36, about here. And now we're halfway done with the data points. 4350, 43, and up to 50, right there. Over 9, up to 79. 2275, over to 22, up to 75. 5828, over to 58, up to 28, about here. 7510, over to 75, up to 10. 6223, 6223, up here. 3264, over to 32, up to 64. 7018, 70 and up to 18. Okay, so I'd say this is a strong association. They're all very narrow, so they all fit in a very narrow hallway. It's a linear association. I could use a straight line to very well represent this data, which we're going to do in a moment. And it's a negative association, meaning if we were walking from left to right, we would be walking downhill. Okay, so they kind of gave us some help on figuring this out. I know that we're going to need to find the slope, we're going to need to find the y-intercept, and we're going to need to plug those into y equals mx plus b, probably more than once. Okay, so estimate the y-intercept from the graph. So let's go ahead and make a line of best fit. This is sometimes just a judgment call. I'm going to, I'll do that for a line of best fit. Does it look like I'm getting about half over and half under? Yeah, we can do that. May not be perfect, do your best. So that's a pretty good line for a line of best fit, goes right through most of these. I would say the y-intercept, it looks like the y-intercept is at right about 90. So y-intercept of 90. And that was right there. Now choose 2 points to use to find the slope. So they gave us 2 to use, didn't they? So they gave us 12 and blank and 50 and blank. So what did they end up picking? So they ended up picking 12 and blank. Looks like they picked this one. So 12 and 80 is what they picked for us, and 50 and blank. So they picked 12 and 80. Let's identify that. So that would be about here. And they also picked 50 and blank. What point did they use for that? 50 and 38. So it looks like they used here, maybe that point. Okay, so what we're going to find now is there's going to be this slope. It's a downhill slope. And we're going to be looking at the change in y over the change in x. And we do that by doing the y2 minus y1. So I'm going to do 38 minus 80 over 50 minus 12. And let's do the math so you can see what I'm calculating. Okay, so 38 minus 80 is negative 42. That goes on the top here. Over 50 minus 12, 38. Okay, so what is that? Can we give it, round it to the nearest tenth perhaps? 42 over 38. That's the reduced form. Let's go ahead and give it as a decimal. So maybe 1.1 for m. And of course, that's a negative 1.1. Okay. So now we're going to write the equation. So use the y-intercept and the slope to write the y equals mx plus b. So what do we know so far? We know b is about, we'll do our orange. So b equals 90. Green, we just found our slope m to be the negative 1.1. So y equals negative 1.1x plus 90. So there, now that we have a equation, now we can figure out what they were ultimately asking us for. So what were they asking? So construct, we go up to the top, construct a scatter plot of this data, sketch a line of best fit. We did that. Find an equation for it to estimate. We just did that. And we want to use it to estimate temperature for a location at 25 degrees north. So I just realized this could be really confusing, right? Because temperature is measured in degrees Fahrenheit. Latitude is measured in geographical degrees. So that's a little bit funny. So we want to find the temperature for the location at 25 north. So we're going to plug 25 in for the latitude, which is x. So we're going to replace x with 25. And they did help us out with that. So y equals, oh, we solved this a little bit too early. So they wanted us to just put y equals mx plus b. We did that already. So we just figured out, of course, we figured out earlier that m is being replaced with negative 1.1. B is 90. And of course, when we're going to do the math on that, we're going to plug in 25 for x. So let's do that together here. So negative 1.1, oops. Let's do 25 times negative 1.1. And then we're going to add 90 to that. So that gives us, okay, what was that intermediate step? Negative 27.5 plus 90. And the final y is 62.5. So what is that? What is 62.5? So the equation of this that we wrote up here, so y equals negative 1.1x plus 90, gives an estimated temperature of 62.5 Fahrenheit for a latitude of 25 degrees north. Okay, so we see that this would make sense, right? So if we're at 0 latitude, that would be like at the equator. And at the equator, it's very hot. At a latitude of 90, we can see that we're getting closer to the North Pole. If we're at a latitude of 80 or 90 way up here, so the temperature would be 0, or looks like it's about 0 if we plotted that at 90. Okay, so what do you think? Do you have any questions about that? Put that in the comments. If you're watching on the behind the scenes camera, you can always go to Florida Math Live to catch the full experience. I'll stay on for one more moment to answer questions. I'll zoom out on this page so you can ponder that again if you would like. Of course, these videos are also available recorded afterwards if you need to go back and work over something, have another look. And you can always message me if you have questions. Put them in the comments while we're working. Like having this be an interactive thing that can help with what you're stuck on. If you're also finishing up something for summer school or anything like that, I can answer any of those questions for you, okay? Okay, looks like we have everything answered for everyone. Stay on for a few more seconds. Okay, I'll go ahead and wrap up. If you have questions between now and tomorrow evening's video, send me a message and we can get that covered. In the meantime, thank you very much, everyone,